Yeah. Now, coming to the multiple stack. So far you have understood the concept of stack. Stack is what? It is a linear data structure where we store the data in the format of last in, first out. Whichever the element uh, has been inputted, the last, that will be the element to be expelled out fast. Okay, last in, first out. So likewise, why the implementation and the usage of multiple stack came into existence? What is the usage? So we will see how to create the data structure using the multiple stacks with a growable size, means as per the requirement of the size, how we are going to grow the size of the stack and how we are going to handle these operations into the multiple stack. The basic operations of the stack is pushing an element, popping an element outside and finding the topmost element. So in the multiple stack as well, we will be pushing the values, okay, of x onto the stack numbered with the stack number. Okay, stack 1, stack 2, stack 3 will be available to you. So with respect to the stack numbering, you will be entering the element into it. For example, I can say here, I have to input the value as 2 in stack 1. Similarly, I want to input the number 3 in stack 2. So that's how we will push the elements into the stack with respect to the stack number. Similarly, popping. So this is with respect to push. Now coming to the pop, if at all you want to pop the element, so pop the element, pop will always taken from the topmost element. So no need to represent the element here. Directly give the stack name. For example, I want to pop any of the element from stack 1, just give the number of the stack. Whatever the element you have to be deleted, that will be the topmost one. So simply give the stack number, it will be helping you to pop out the element. And finally, find the topmost element. So give the function as top of stack 1. So it will return whatever the topmost element available. For popping, you will use the function name as pop. For pushing, you will be using the function name as push. So hope I'm clear here. By using the concept of multiple stack, we will be implementing the operations upon the multiple stack as pushing, popping and finding the topmost element of the stack. So here is an example. Suppose in the given multi-stack, we are having the elements as 1, 2, 4, 6, 9 and 10. So input push. So we are inputting the element as 3, 0 and top is 0 there. Pushing again 7, 1. Okay, into stack 1 we are entering the element as 7. Again pop 2. So from the stack 2, you will be popping out the element. Now, if you see, what will be the output? Remaining elements are 3, 7 and 9. Okay. So, that's how the multiple stack will be applicable. So, here you can see 3 is pushed in stack 0. So, if you see here, element 3 is pushed in stack 0. So, the stack becomes 1, 2, 3. So, first here it will become 1, 2 and 3. First stack has 3 elements into it. Now, when 7 is pushed in the stack 1, this is a stack 1, stack 0, stack 1, stack 2. Now, 7 is pushed in the stack 1, so it becomes 4, 6 and 7 and the topmost element here is 7. So, that is the last one. And finally, if you see in the stack 2, already there is 9 and 10. So, we are inputting what there? 2. So, we are not inputting anything, we are just popping out one of the element from it. So, 10 will be popped out and the topmost element there will be 9. So, this is how the implementation of the multiple stack takes place. Now, coming to the applications of stacks, if we see, stacks are applicable in our day-to-day life in so many areas, okay, like the usage of the lift, I can say, how it will be applicable. Similarly, in the function calls, stacks are used to keep track of the return addresses of the function calls, allowing the program to return the correct location and finishing the execution. Function calls in the format of order which function call has been called first, with respect to that it will be executing, and it will be returning back to that particular line during the execution time. Similarly, it will be applicable even in the recursion. Okay, recursive number of function calls will be applied upon the stack, means repetitively that particular function has to be called, right? So it will be implemented by using the stack concept. Expression evaluation, this is also one of the important concept, that is the application of the stacks, where we will be applying this infix, prefix and postfix notation, and postfix is also known as reverse Polish notation. Next is what I can say, syntax parsing. So here also we will be applying the stacks for the validity of the syntax in the programming language and the other formal languages. Memory management, allocating the memory in the operating system and other programming languages, we will be applying the stacks only. Okay. Now, coming to the expression evaluation and conversion. So, in this concept, suppose for example, you are having one of the expression as okay. So, suppose the expression is in this format, or if not, we are having certain examples are already given. I consider that example. Let me consider here, evaluate an expression represented by a string. So, for evaluating the expression with respect to the string, what we are going to do here is, the expression can contain the parentheses that you can assume that to be a parenthesis are well matched. For simplicity, you can assume only binary operations which are going to allow you plus, minus, multiplication and division operation. So, while implementing the arithmetic expressions, it can be written in either of the three forms, that is in the infix, prefix and postfix notation. Example, here we are having two operands and there is one operator in between, we are performing the plus operation. So, since it is infix, the operator will be in the middle of the two operands. Since it is prefix, the operator will be prior to the two operands, and in the postfix it will be 3, 4 plus. Okay. So, this is how the expressions will be evaluated based upon the infix, prefix and postfix. It will be based upon the order of the arithmetic operations or any of the order of the operators. There can be even parenthesis can be included, and not only the parenthesis, you can also make use of the plus, minus, multiplication and division signs for the arithmetic operations there. And let us see one more example here. This is my given string. Okay, I have to evaluate it. What should be done? The string is 10 into 20 plus 10. So, the highest priority which is given to the multiplication sign. So, if I multiply 10 with 20, the answer is 200. Then the final operation is 10. If I add them, the output is 210. So, this is how we are going to evaluate the given expression. So, this is the expression which is in the form of a string, and we are going to evaluate it by performing the operations based upon the precedence of the operators. So, the first priority here is given to the multiplication sign. So, we are multiplying 10, 20. So, it is 200, then we are performing sum upon it. 200 plus 10 is 210. Now, second one is, if you see here, we are having multiplication, division and minus sign. So, if you see there, the priority that is having equal precedence, priority is for this multiplication and as well as division. So, what we will do here, we will first multiply 16 5s are 80, and next we will divide 5 by 15. Okay. One by 3. So, the answer would be 80 minus 1 by 3. So if I perform their LCM, so the answer is 80 there. So that's how the output is given to you after performing the multiplication and division sign. Now, let us look into detailing of infix, prefix and postfix expression. So what is it? Before we start writing the code for any evaluation of the expressions using the stack, let us kindly understand the terminology of infix, prefix and postfix. Let us see this. The usual expression, whatever you see, it will be in the infix format. So this is in between. Okay. So this is my given example in the infix format, where the operands will be having the operator in between them. So that is an infix representation. Postfix, after the expression, after the operands, the operator will be appearing. So this is the postfix of the previous infix. So if you see the postfix of this, it would be AB, C will be coming and plus will be coming there, multiplication will be coming. Okay, then division, D, after that division will be appearing, right? So similarly here now for prefix, all the operations will be coming prior towards the operands, right? So this is a prefix representation, postfix, and the previous one is infix, where we are having actual representation of it.